Segment partition. Let's begin working with this topic using example number 1. Ideally, I would like you to pause the video now and try to solve this problem on your own. Text annotation should be always your first step. We will identify key mathematical terms in the problem by circling them. We will underline numerical information, and we will squiggly line that part that represents the question of the problem. So as a result, your annotation will look somewhat like this. It's also a good idea, especially for more complex problems, to write out facts one at a time in a given and find columns. This little fact is actually very easy to miss, but is very important. This is just numerical information kind of facts. And the question itself, find the value of m, is what we need to find. The reason this piece of information is so important is because it tells us that there is a segment named T, P, R. This notation means two important facts. It means that points T, P, and R are actually collinear, and they are in that order, with P between T and R. All that means that your diagram only could look this way and cannot look like somewhat like this. Now let's continue labeling our diagram with the information about the pieces. As we do that, we want to keep in mind what each of these quantities stands for. Does it represent the length of the entire segment or just a piece of it? Because what we have in this situation, according to this piece of given, is that two parts create the whole with no special qualities of those parts. We don't know if they're equal, and we will not be assuming that. So this little word right here, or symbol for segment TPR, tells us that we have segment partition and betweenness. So as part of the solution, I will restate that fact that segment partition would mean one part of my whole segment plus second part of my whole segment will actually make that whole, which is TR in my case. I will then continue with substitution using proper geometric symbols to name each of these parts. So according to the given, my TP and PR and TR are now on the diagram. Including the question itself, I will be finding M. Later on, I will continue with finding segment PR, which is right here. That is why you see that I marked it as unknown. So, using the substitution for first part, we will express it in geometric terms, TP, second part PR, and the whole is TR. Then we'll continue the substitution in algebraic terms, since TP, according to the given, is expressed as 3m minus 4 and PR as 6m plus 2. Notice that I'm using parentheses because these quantities represent a numeral, the actual length of the segment, just in disguise, and then TR. As a result, from the first simple statement, the only fact that we can insist is true about this diagram, we received an equation. And to solve this equation, of course, we would have to observe for what complications we have. We have two pairs of parentheses. So we'll look at the latest pair. And in in front of it, we will notice that there is a positive sign, which means it's a multiplier of positive 1. In front of the first pair, there is a hidden positive 1 as well. We know that multiplying by positive 1 does not change the signs of any terms. Therefore, my next line simply will look like I removed the parentheses from the expression on the left. And the expression on the right didn't need any change. I now will notice that I have 1, 2, 3 terms. 2 of these terms are on the left. So I'm going to rewrite like terms together so I can see which of them I can combine, simplifying their family. On the right side, there are only 2 terms and they belong to different families. So I cannot simplify the right side. But right here on the left, 3m and 6m produce 9m, whereas minus 4 plus 2, double check with the calculator, will produce minus 2. And of course, the right side will have no change. Now I'm noticing that in my equation, variable terms are both on the left and on the right. So it's my choice whether I want to get rid of 5m or 9m. I prefer to get rid of the smaller term because that allows me to avoid working with negative numbers. So I will get rid of 5m. It's a positive 5m. For that reason, I will be subtracting 5m to undo it from both sides. As a result, on the left side, I will end up with 4m and still minus 2. But my right side will now only have positive 22. My variable term is now only on the left, 4m, and to isolate it, I will need to get rid of minus 2, which means that I will undo it by adding 2 to both sides, and that will make my expression on the left as 4m, and the right side will simply become 24. I already understand that you'd divide by 4 both sides, getting your result for m as 6. So right now, we satisfied this first question. Got that? The value is 6. And moving on with next question, finding the value of PR. Let's observe where PR is. It's very important to find it on the diagram so you accidentally do not start plugging in your m into an expression that represents a different segment. So PR is an expression represented, or segment rather, represented by the expression 6m plus 2. So for that reason, I will begin my computations with stating then PR is 6m plus 2. I don't want anybody to misunderstand what it is that I'm doing. So I will copy this expression, which you should too. It's only a second of your time, including showing the substitution. So for m now, I will pick my 6. And then computing 36 plus 2, my conclusion will be that the length of PR is 38. And since it represents a length, I'm going to say that it's units. It is important to realize that verbally, the same solution would be appropriate, not just for the problem that is stated in this way. Instead of segment TPR shown in symbols, you also could have had something like this, that TPR are collinear and are in this very order. This would mean exactly the same kind of a statement in symbols, and it would mean that only this kind of a diagram is possible. It also could be stated if P lies between T and R with the given lengths, then what would be the value of M? In this case, the diagram is only appropriate in this form. Another situation that would describe exactly the same diagram is a line intersects segment TR. So you actually might have some sort of a line intersecting segment TR at this point P, and point P in that case would be a point of intersection, that is a point between T and R, and therefore the situation of segment partition also will be present. Okay, let's take a slightly different question, question number 2. Please copy it and try to solve it all by yourself. And I will do it together with you, starting with annotating the text. So once again, the key information, the keywords, mathematical terms are circled, numerical information is underlined, and squiggly lined question, so it's easy to identify it at the very end and make sure that you are done answering that very question. I also will model how to restate the conditions in your own words and rewrite them into given and find. Again, I believe it's important, especially for more complex situations, so you don't miss any fact if you force yourself to break down the text into little pieces. And we're looking for the value of M first. Then we will look for the length of PR. Based on this information, again, we have point P between T and R. All of these points are collinear, so the only way this picture could start is with the segment, like on the diagram. Then I have TP, TR, and PR parts identified. So my thought process again goes to the fact that there is a segment and there would be partition. I will not let anybody be guessing about my train of thought. I will clearly state that since I recognize only segment partition here is definitely present, I will be working with parts that give me the whole. Then I will continue the substitution for every part. In this case, it is TP, then second part is PR, and my whole now is TR. And the difference between this example and the previous, which we just did in example number 1, is that these pieces of information belong to different parts of the segment. And therefore, although your generic equation, the rule itself, will look the same, the pieces that you add would be different. You now would be adding your 3m minus 4 with 5m minus 22, and the whole this time is represented by 6m plus 2. The rest is the same kind of an algebraic equation, so you will have to be removing your parentheses with the multipliers of positive 1, which will look like we simply have dropped the parentheses, no change in sign. My next move will be the same. I will be regrouping like terms so that I can combine them next. Think what the result will be for yourself. We are combining the family of m, that would be 8m, then minus 4 and minus 22. Check with the calculator. It will be minus 26, and there is no change to the right side. Again, observe that your variable terms are now on the left and on the right. Good news is that it's only one term with a variable on each side, and you now can get rid of the smaller of them, which is 6m, positive 6m. So we'll subtract it from both sides. And then as a result, your equation will turn into 2m minus 26 and 2 on the other side. Now the variable is all the way to the left, and you need to get rid of minus 26, which you will undo by adding 26 to both sides, resulting in the equation 2m is 28. Of course, now to isolate the m, we will divide by 2 to undo multiplication by 2. And m will be 14. So that completes our work as part A of the question. Remember, we also have part B, where we're looking for the value of PR. So take a look at what PR actually is on your diagram. PR is a portion described by the expression 5m minus 22. So I will start my work with stating that fact. Then, since PR is 5m minus 22, substitution comes in. The value of m was 14. Double checking with the calculator. The value of PR that I found is 48. Since it is a length, once again, I will state that it is in units. Again, it is very important to realize that this is not the only verbal form of describing this situation. Instead of TP segments, you could have had the words that T, P, and R are points collinear and are in that order, or that point P lies between T and R, or that some line intersects TR segment through point P, making P a point on that segment and between T and R. The difference between this example and first example was only in the position of the segments described with certain algebraic expressions, which you have to be aware of and label it with care. Otherwise, it will result in an incorrect substitution and a different answer, just like we had it now demonstrated in these two examples.